So this is Kerberoasting Revisited. I'm sorry to spoil it for anybody. There's no new tool drop, nothing revolutionary, but I'm going to try to deep dive on some Kerberoast internals and some Kerberoasting stuff, some OPSEC stuff, and a few things that we weren't aware of up until recently. So the super quick, who am I? My name is Will Schroeder. My handle is Harmjoy. I'm a technical architect. Thank you. I'm a technical architect at SpectreOps. Thank you, Matt. Written a lot of code over the years, helped out with Veil, Empire, RIP Empire. Someone can yell at me later for that. Some PowerSploit stuff, Bloodhound, Ghostpack, and the one tool I'm going to be covering in this talk a little bit is Rubius, which has been the new fun thing I've been working on. I've talked at DerbyCon since DerbyCon 4, so this is kind of where I kind of started, helped build my career, so it means a huge amount to me. So again, the TLDR, what I'm going to cover in 20 minutes. So Kerberoast in 20 minutes. It'll make perfect sense. I'm going to try to cover exactly how Kerberoasting works specifically. I'm going to talk about approaches, specifically kind of outside in within Packet versus on host and some of the .NET requester token stuff. I'm going to cover MSDS supported encryption types. Who's ever heard of that property? Anybody? Okay, a handful of people. Hopefully it'll make sense and why it's important from the Kerberoasting standpoint. The steps towards us trying to build a better Kerberoast and kind of the stuff that's coming up next. This is also the 5-year anniversary of Kerberoasting. So Tim Medine at DerbyCon 4 released an awesome talk that I understood 10% of called Attacking Kerberoast, Kicking the Guard Dog of Hades, where he covered the nascent components of silver tickets as well this whole Kerberoasting type thing, and this whole attack kind of came about because he was just reading Kerberoast documentation. So really appreciate all of Tim's work. Always try to give him the shout out. He is the one that came up with this technique that we all now use. So I've got my fancy diagrams of trying to explain the parts of Kerberoasting and how it works. So one thing that really helped me understand this is think about hosts on a domain, not as a singular monolithic thing. A host is a collection of services that are backed by Kerberos. For example, you got PowerShell remoting, WMI, file shares, MS SQL, whatever else. These are all going to have service names or S names that are that first part of a service principal name that we'll talk about. So let's take, for example, CIFS, and we're an attacker or a legitimate user, and we run dir computer.domain.com. We've already done our authentication, we already have our TGT and all that fun stuff. So what will happen is implicitly in the background, your computer will take that TGT and say, hey, I want a service ticket for this particular service that maps back to the action you're trying to do. So in this case, CIFS, Common Information File System, is going to track back for the file share access. The domain controller will return that nice little service ticket for CIFS, that service principal name that maps back to the action you're requesting. And then the attacker or legitimate user is going to present that service ticket to the actual service. So that's the super high level. This is like this is the area that we're talking about for service ticket requests and service ticket usage. To go into a little more depth, we do that dir computer.domain.com. We want that CIFS. What actually happens under the hood with the domain controller is the DC will look up which user or computer account has that particular service principal name registered to it. So again, it could be a computer dollar account, it could be a user account, whatever else. Because that service principal name is just going to be registered as a property for some account in the Active Directory database. The DC will look up which one of those maps to it. And then it'll return the service ticket where part of the service ticket is encrypted with the key of the looked up account. In this case, that's computer dollar, but this can also be a user account. And then the attacker or legitimate user presents the ticket to the target service, and it's encrypted with that shared computer dollar key because the computer has a copy of its password and the domain controller has a copy of its password. And then also one key note is the target service decides whether or not to grant access. It's not the domain controller. DC only does authentication and verifies like I'm Will or I'm the attacker, I am who I say I am. That target system is what actually decides whether or not to grant the attacker access. Cool. So makes perfect sense to everybody. You're all now Kerberos experts. I've been dealing with this stuff for like 4 or 5 years, and there's still things that I discover all the time that I didn't fully understand. Every time I think I have a complete grasp on it, I read some other thing or learn something else, and then my mind gets blown. So it's dense, it's hard, but the more you kind of get exposed to these systems, like at some point this stuff will click in your head, and then a lot more of these attacks will start to conceptually make sense. But some of the key points here is that target service and the domain domain controller have to share some key so that service can decrypt the ticket that the DC sends to the user. For most service principal names, this is the computer dollar account hash, or the key. It could be AES, it could be RC4, a bunch of these different encryption types that we'll touch on. For computers, they always have basically a randomized password that changes every 30 days. So when you get that service ticket back, you could theoretically crack it or try to brute force it, but it's not going to be realistic. You're basically just guessing. Boo. But if the service principal name, that property, is registered for a user account, we can now, through this service ticket request, get a piece of encrypted information that we can crack offline to decrypt their password. This is all Kerberoasting is. It's just requesting a service ticket that's registered to a user Active Directory object, and then extracting part of that and cracking that component offline. So like with Kerberoasting, you don't get like a hash, it's none of that or whatever. The representation that you get that you pass to Hashcat or John is a encrypted representation of part of the ticket structure. Also, a couple more things with the crypto. So service tickets, just like ticket granting tickets, will generally either use AES-256 HMAC. I'm just going to abbreviate to AES-256 here. Or RC4 HMAC MD5. So this typically is called RC4 in Kerberos. This hash is also the same hash that's used for NTLM. So sometimes there's like some confusion there. But in general, we call it RC4 for Kerberos. We really want service tickets returned with RC4 because it's orders of magnitude faster to crack than AES tickets because the key derivation used and the salting and all that kind of stuff. Up until recently, there actually wasn't anything that let you even attempt to crack the AES tickets. So, okay, that's the background in crypto and all that. So why should you actually care about Kerberoasting? Cool things with this that Tim covered in his original talk is any user can request any service ticket by design of how Kerberoasting works. That target service doesn't have to be up or whatever else in the SPN. You just have to be able to talk to the domain controller, have a legitimate TGT, and then request service tickets for whatever you want. No packets are actually sent to that target service that's a part of the SPN unless we try to actually use the requested ticket. So again, you're only communicating with the domain controller for the Kerberoasting component of this abuse. So the translation of the TLDR is if a user Active Directory, if a user object in Active Directory has a service principal name registered to it, we can crack that user's password offline using GPU accelerated Hashcat modules. Awesome. So how can you actually use this stuff once you crack it? There's a couple notes and there's a few things sometimes people forget about. So if a user has an account with an SPN registered, the user usually has admin privileges on the machine targeting the SPN, or they're part of other privileged groups. But in some cases, this isn't true. But even if they aren't privileged on that target system in the SPN, because that user account is now acting as an oracle for that particular service principal name, with the key cracked, you can forge any tickets, you can forge tickets as any user to that specific SPN. So you might be able to compromise things, you might not. Say for SQL, you could pretend to be a DA or anyone else to actually connect into the database. You don't have to pop the system. So now, operationally, I'm going to talk about the two main approaches that our industry has historically used for Kerberoasting. One of the most, how many people do it with Impacket? How many people do it with PowerView or Rubius? Oh, not enough. Okay. I'm going to try to make the case for this. So downsides with Impacket are that external N, where you're like SOX proxying traffic in, is you need credentials. So you need a legitimate password or hash of an existing user. And it can be more difficult over high latency command and control. When you're piping all the traffic components in, because Impacket awesomely implements the entire Kerberos stack on the attacker side, this can be in some situations more difficult if you're talking about like a 1 hour callback interval or something like that. You need to have an interactive session essentially to be able to do the full traffic exchanges without timeouts. But an advantage is you can granularly control all the aspects of the exchange. So you can say, I only want RC4, and like you can construct the packets and requests in any way you want. From a domain join Windows host, how we've traditionally done it, is you don't need credentials. You just need execution in a domain user's context. So that's an advantage. It's easier over high latency command and control because you're using Windows internals to do the request and extract everything out. That's an advantage. But up until recently, the built-in request methods don't let you control aspects of the exchange. Like, you can't say, I just want RC4, or you can't control the different components of the packet. Because you're just letting Windows internals do all the exchanges and pull it down. You can't actually control the pieces of it. So the main way that this is done on the Windows host, which is what I'm going to focus on for this talk, is people have used either setSPN.exe, or there's a .NET method called Kerberoast Requester Security Token that lets you request service tickets for target SPN. Traditionally, like the original talk that Tim had given, is you use this to request the SPNs, and then he would use Mimikatz to carve the tickets out of LSASS. Now, more and more commonly, that's not OPSEC safe for different EDR products, will stop the manipulation, either read or modification of LSASS's memory. A couple of years ago, Martin Hart, MachoSec, realized that there was an additional method in this class that let you get the bytes of the request out, so you could carve the tickets out without being elevated and without having to attach to LSASS. So this is what PowerView has used for the invoke Kerberoast method for a long time. So things are starting to get better. A couple more side notes, though. I keep talking about like RC4 versus AES. And part of the reason is modern domains, so 2008 functional level and above, are supposed to use AES keys by default for Kerberos. Functional level 2003 just had RC4, 2008 upgraded to AES keys, everything got re-rolled. So everything with TGTs and service tickets are supposed to use the highest mutually supported encryption, which tends to be AES 256. So requesting an RC4 service ticket should result in a heuristic called encryption downgrade. This is also applicable, say you're doing like golden ticket forgery or something like that, and you're using the RC4 NTLM key. That's going to be weird because in a Windows 7 and up system that's communicating with the DC, you should be using AES 256 for those exchanges. This is actually a heuristic that like Microsoft ATA and things will do. And what we thought for a long time was like, okay, this is a great heuristic from a defensive side. If you're actually gathering all these event logs and all the request stuff and you get the information, then anyone requesting RC4 service tickets should be weird. Has anyone tried to baseline that in an environment? Like, everyone knows it's a giant pain in the ass and there's 10 billion false positives. I'm going to explain why. Because most user-backed SPNs almost always return RC4 service tickets, and we didn't know why. So this is an example there of like, okay, up top, this is just showing the ticket information. I have an AES ticket for my current user Harmjoy, but when I'm requesting a service ticket for the MS SQL service, SQL test lab, whatever, that ticket is returned with RC4. And these are just using built-ins. And we're like, why is this happening? And the reason, as almost always, is in the Microsoft docs. We just didn't actually understand them or fully read them. So there's a property called MSDS support encryption types that was actually touched on by Jim Shaver, Mitchell Hennigan in their DerbyCon 7 talk 2 years ago on some of these topics called Return from the Underworld. And according to Microsoft's own documentation, this property, or the KDC, so the domain controller in this case, uses this property when generating a service ticket for the account. So what this means is this property will say like AES, RC4, whatever else, and any service tickets being requested for that account, an SPN for that account, the DC is supposed to use this property and say, okay, I'm going to return AES or I'm going to return RC4, here's what's supported. So according to MS Kyle, more Microsoft documentation, the default value for this field is hex 1C. So this is a binary OR of RC4, AS128, and AS256. This is the default value for Windows 7 Plus and Server 2008 Plus. Cool. But this property is only set by default on computer accounts, not user accounts. User accounts is just blank. And if the property isn't defined or is set to 0, then MS Kyle says the default behavior is to use RC4. So for all user accounts that don't have MSDS supported encryption type set, by definition, Microsoft's own definition, they can only return RC4 service tickets. This is why, and we only care about user accounts that have SPNs when we're Kerberoasting. So that's why there's been so many false positives over the years if you try to actually baseline this activity. The good news is we can manually set user accounts to explicitly support AES 128 and 256 encryption. This is just ADUC, Active Directory users and computers, says this account supports AES, whatever encryption, and the values, say we just do this, and we don't say we support RC4 explicitly, then the values will be the binary OR of AES 128 and 256. Awesome. So therefore, this account, the SQL account, should now theoretically always return AES. But that's not the case. Microsoft didn't actually follow their own documentation. And I don't know exactly why. This is an example of that exact account in the lab that I set, where you see, I know it's kind of hard to read, and I'll release these slides after the talk, but supported encryption types, for MSDS supported encryption types, says AES 128 and AES 256. That's all it says. But if I hard specify RC4 in the request, I'm getting a type 23 and RC4 HMAC ticket back. So this was always possible with, say, Impacket. It was not possible with the built-in encryption types, or the built-in encryption requests, because when we're using that .NET requester token type stuff, it's always going to request the highest mutually supported. So that's why sometimes when you've Kerberoasted with PowerView, you get AES tickets coming back. So why should we give a crap about this? There doesn't seem to be an easy way to disable RC4 service ticket requests on user accounts. So we can't stop RC4 Kerberoasting. It's not possible. You can disable RC4 for the entire domain, but this also kills RC4 ticket granting tickets. This will break every single environment I've ever heard of. No one's ever going to do this. But if you set AES support explicitly for all user accounts, or all user accounts that have SPN set, you at least get an encryption downgrade heuristic, or you can tune down some of those false positives. All right, now I'm going to take because I know I only have about a few minutes left, but some of the downsides for doing the built-in request methods. Using .NET or SPN, what this ends up doing is it'll cache a service ticket for every single SPN you're requesting on the host. So if you Kerberoasted 100 accounts, you have 100 service tickets left in the cache in the current logon session on your host. That's just kind of how it worked. So that just feels like bad OPSEC to me. That feels kind of gross, because if someone has the ability to look at that information on the host, they're going to say, why the heck were you requesting like 150 different random service tickets? And again, this is because the Kerberoast requester security token doesn't let you say, I only want RC4. It's just going to request the ticket, and all the stuff underneath the hood is going to say, we're going to use AES. And the reason we can't do that or specify stuff is we don't have a full proper ticket granting ticket. So we can't manually specify the fields like we can in Impacket. If you're elevated on the host, you can always rip the TGTs out, but we want to be able to do this stuff when we're not elevated on the host, and we don't want to rip things out of LSAS or LSA. So Gentle Kiwi, Benjamin Delpy, realized a trick where we can prep an outgoing service ticket request for an SPN on a server with unconstrained delegation, which is always guaranteed to be the domain controller. And this results in a delegated TGT for the current user being present in the outgoing request that's prepped in a way that we can carve the forwarded TGT out of memory. So we're not touching LSAS, we can just carve it out of the request. What does all that mean? As an unprived user, we can get a usable ticket granting ticket for our current execution context, full usable Kirby. So what can we do with this? So Rubius is a re-implementation of a bunch of Benjamin's Kikyo project, and it implements all the Kerberoast structures and exchanges by hand. It was not fun. It was, yeah, one of the most painful things I've had to code, and I had Benjamin's, well, if anyone's read Benjamin's code, yeah, it's completely documented, and yeah. But I implemented the whole stack, everything's great, and I also implemented the Kikyo, or the TGT delegation trick. So combined, this means we can get a usable TGT for our current user, and then hand build all the service ticket requests, send them out, carve everything out, and we can avoid caching those tickets on the host. So we don't have like 150, 1,000, whatever tickets cached in our current logon session, and we can manually specify RC4 in the service ticket request. This is what Rubius does. This is from the README. If you do Rubius Kerberoast / TGT DLEG, this will use that trick, do the request, and then hard specify RC4 for the downgrade component. So this is the most OPSEC friendly. If you want to avoid any like that heuristic downgrade type detection, there's actually an RC4 OPSEC flag, which will only enumerate accounts that don't have AES set and MSDS support encryption types, then do the TGT delegation trick so it doesn't have to manually specify RC4. So that way you avoid potentially tripping up that encryption downgrade heuristic. Cool. That's most of the material. There's two slides left kind of saying like what's next with Kerberoasting. So Fistors did an awesome pull request to Hashcat a few months ago after we were going back and forth revisiting some of this. So you can actually crack AES 128 and 256 tickets now with Hashcat. And again, it's going to be about 1 to 2 orders of magnitude slower than RC4, but we at least have the option of doing this now. And Rubius can request the AES tickets if you want. And when I was putting this together about a week ago, in the Bloodhound Slack, we have a Kerberoast channel, and someone was mentioning, I won't read all this, but basically what they're saying is, okay, we're enabling AES for all the services, so RC4 shouldn't be seen. However, a bunch of accounts still keep getting RC4 back. What we figured out is if the password was last set when the functional level is 2003, when RC4 is all that was supported, AES keys for that account won't be generated until the password is reset at the new domain functional level. Also, even with that, you basically have to upgrade the domain functional level, reset the password, set MSDS support encryption types, and then reset the password again because there's some nonsense in the background that Microsoft is doing. So even if you're doing everything right, this is like how hard and nuanced this stuff is. We can still, like this person knows what they're doing and they're trying to actually fix all this stuff and they're like pulling their hair out of like, why the heck can't I like stop these stupid RC4 tickets coming in? So there's a more complex process for this if you have a super old domain, but it is possible. So thank you guys. There's Rubius is on GitHub. My credits to everybody, Tim and Benjamin, Alberto, Fistors, and Martin. So yeah. Thank you guys for coming out. Oh. And again, I will tweet these slides out. I'll put them up on SlideShare in like an hour.